Good day and good afternoon to Dr. Devi. In this session, our Group 4, will be presenting our final project findings for the information retrieval course. Our group consists of three members, Irene as the group leader, Amira, and myself, Harits. On this session, we will go through four different parts, which is introduction part, scores of P at 10, AP at 10, MAP, correlation coefficient, and lastly, significant testing. To begin with, let's start with introduction. Here we are looking at the system run files, which simulate the record list of documents written by search engines for specific topics or queries. Each file represents the output of a retrieval system showing the topic ID, document ID, rank, score, and system name. And here we are looking at the QROS files, which are the relevant judgment file provided by the track website. So on the second part, we will discuss our findings on scoring for these three metrics. So the first one is precision. Precision at 10 or P at 10 is a widely used metric in information retrieval to evaluate the accuracy of a search system. It measures how many of the top 10 retrieved documents are relevant to the user query, focusing on the quality of results rather than the quantity. A higher precision indicates that the system returns more relevant documents with fewer irrelevant ones. In this project, P at 10 was calculated for 15 different systems to compare their effectiveness in retrieving relevant documents. So P at 10 scores were computed using the Track 8 ad hoc QRLS files, which provides relevance judgment for each topic, and 15 system run files containing ranked lists of documents retrieved by each system per topic. Next is how the code processed the calculation for P attempt, where as you can see on the right side, where the steps starting from data preparation and rank order validation, computational analysis until result display. And so this is the result of the code that are displayed in CSV form, in table form, and it is also show the system ranking by average for P at 10. And so this is the observation summary for P at 10 that show our top performer system, lowest performance, and moderate performance. And it can be concluded that for this system precision scores, 10 out of 15 systems score above zero point 0.3, indicating generally good top 10 precision.
Next, we will move on with average precision at 10, whereby this rank sensitive metric used in information retrieval to evaluate the quality of a ranked list of search results. So unlike precision at 10, which only considers the number of relevant documents in the top 10 regardless of their positions, AP at 10 rewards systems that rank relevant documents higher within the top 10. So this makes AP at 10 particularly useful for measuring how well a system prioritizes the relevant results early in the list. So the methodology to compute AP at 10, the first step is only the top 10 retrieved documents for each topic were considered. Second, for each relevant document within the top 10, the precision at its rank was computed. For example, if the top 10 retrieved documents are D1 to D10 and relevant documents are D2, for example. So precision at D2 means that document D2 is positioned at the second rank, but it was the first relevant document. So it will be, the precision at 2 will be 1 over 2, which is zero point 0.5. So this is repeated for every relevant file in the top 10 retrieved documents. And for the AP at 10, we need to calculate, we need to total up all the precision sum and dividing it by the number of relevant retrieved documents. So if no relevant documents appeared in the top 10, the AP at 10 score was 0. So this is the Python code for calculation of AP at 10. So the step is, the most important one is we need to validate the rank order. We need to make sure that number one is on the top, because we need to make sure that the top 10 is the most relevant one. So this is to validate the rank order first. After that, I've reassigned it to the clean file, whereby during this validate rank order processes, it will generate a new clean file, a new order file. So we reassign it to the clean file, and then after that we load the relevance judgment and perform the calculation or comparison from the system run file and the QREL file, and then generate the AP at 10 matrix and calculate average of AP at 10 matrix. So this code uh, explains everything in the steps. So this is the result of the Python code implementation, where we can see that the precision score for each system and per topic. So this metric is being generated, and the most bottom one is the average score AP at 10 that is being calculated. So we can see which system actually performs well or not well. And on the left side is the system rankings, which system has the most highest AP at 10 and the lowest AP at 10. So few observations could be made whereby we can see that system 2 and system 9, also system 1, has the highest AP at 10 scores. For example, system 2 0.8255. So this system actually, it means that these three system consistently return relevant documents early in the rank list. So it's contributing to their high scores. For a moderate system, we can see that system rank 4th to 9, for example, they scores between 0.63 and 0.69. So this is to perform moderately well, but may have ranked some relevant documents slightly lower within the top 10. So this could indicate some inconsistencies across different queries. And the third observation is that system 14 or system 10 with score of the most lowest one 0.2086, this is underperforming by a wide margin. So this suggests that either the system failed to retrieve many relevant documents in the top 10 or rank them too low within the list to earn precision based credit. So, as a conclusion, AP at 10 metrics effectively measures or capture both relevance and ranking order, rewarding system that retrieve relevant documents early, while top systems show strong consistency. The mid-level system might benefit from re-ranking strategies or enhance their scoring models to better prioritize relevant documents. And these results using AP at 10 can guide future improvement by help to identify both high-performing approach and system that need refinement.
Next, the mean average precision MAP. It measures the quality of a ranked list of documents by considering both the relevance of the retrieved documents and their position in the ranking. In the code, we compute the MAP for each system by comparing the entire ranked list of retrieved documents with the relevance judgment from QREL file. For each document in the list, it checks if the document is relevant based on its relevance in QREL file. If it is relevant, it calculates the precision at that rank and add it to the sum. Then calculate the AP score for the query by averaging those precision values divided by the total number of relevant documents for the query. Then repeat for every query from 401 to 450 for each system file and store the result in a matrix. The MAP score for each system is then computed by averaging the AP scores across all queries for each system. This is the resulting matrix and the MAP score for each system in the last row. On the left is the MAP score sorted in descending order. Based on the results, we find that system IIT99 achieved the highest MAP of 0.41, indicating best performance in ranking relevant documents across topics. Then system CR99X followed closely with MAP 0.37. The ISC50 system had the lowest MAP of 0.02. Then other systems achieved MAP scores between 0.3 to 0.4, which indicate moderate and good performance. Different metrics may rank systems differently based on their focus. For this assignment, correlation coefficient test is performed to assess how similar the rankings of systems are when evaluated using different metrics. High correlation means the two metrics rank systems similarly, while low correlation indicate they produce different rankings. For P10 versus MEP, its correlation coefficient is 0.96, means highly correlated. System that rank high in P10 also rank high in MEP. P-value is almost zero, showing it is statistically significant, means the correlation observed is not just by random chance. In this scatter plot, we can see system IIT99 ranked high in P10 as well as MEP. In contrast, system IIC50 ranked low for both metrics.
So the implementation of the code give us the result below the bottom of the code. So what it actually tells us is that the coefficient that actually close to 1 means that the system with high AP at 10 also tend to have high P at 10. So they rank the system similarly. While low P value, which is 0.0000, indicates that the observed correlation is not due to random chance. So the relationship is statistically significant. So a few observations could be made from the scatter plot where we can see that the points form a clear upward trend. So this showing a strong positive correlation between P at 10 and also AP at 10. And this confirms the computed Spearman coefficient, meaning that the system which perform well in one metric also tend to perform well in the other. And system like S2, S1, and S9 appear in the top right. We can see that, and this indicating that they have high scores in both metrics by not just retrieving relevant documents but also ranking them high in the list. And system S10, the bottom left, indicating poor performance in both metrics. This system retrieves few relevant documents and ranks them poorly when it does. And also systems such as in the middle one, showing that their performance is similar, which may explain the non-significant differences in significant tests later on.
So this is the result of significant testing for P10, as you can see on the slides. So as you already see the result of significant testing for precision at 10 on the previous slide, significant testing revealed that 78 out of 105 system pairs has statistically significant difference in precision at 10 scores, with systems like System 1, 4, 7, and System 9 showing distinct performance compared to the others. Systems such as System 2, 5, and System 6 exhibit more similar performance with higher p-values. Highly significant comparison often involve top-performing system, while pairs like System 4 versus System 8 and System 7 versus System 14 show the least different, indicating conservative performance.
The next one is AP at 10. So this is to evaluate whether the difference in AP at 10 scores between retrieval system are meaningful or due to random variation. We can see that a few findings where system S1, S2, and S9 show value 1 against many other system. And for instance, we can see that system 2 shows significance against nearly every other system except S9 and S1, meaning it's likely among the best. And system S3 to S7 have mostly zero values in their rows and columns, especially when compared to each other also. So this implies no statistically significant difference in their AP at 10 score. So they perform similarly and cannot be confidently ranked above or below each other. So this system may be clustered as a mid performance where small differences are not meaningful. And system 3 is the third one is the system 10. We can see that significantly different from almost all system where it has many ones in its rows, but this indicates that it performs consistently worse than the rest. So it is an outlier on the lower end of the performance spectrum. As a conclusion, the heat map helps us to identify which systems are truly better in performance, not just based on score, but through statistically validated comparison.
Lastly, significance testing for MEP scores. At the top system IIT99 with the highest MEP score of 0.41, followed closely by CR99X at 0.38. Statistical tests confirm these two systems perform significantly better than all others, with no meaningful difference between them. The middle tier systems show moderate performance with overlapping results. Then at the bottom, system PLT8 and IBMG perform poorly statistically, but still outperform the worst system, which is ISA50, having MEP of only 0.02.